If you've ever sat in a math class staring at a chalkboard full of strange symbols, you've probably wondered who actually invented them. It's easy to imagine a single genius sitting in a room, inventing the subject from scratch. But the truth is much more collaborative. Mathematics is a global relay race that has been running for 5,000 years. These mathematical tools were originally built to solve concrete life-or-death problems, like feeding a village, tracking the seasons, or keeping a civilization organized. In ancient Egypt, the Nile River flooded every year, washing away the dirt markers separating farmers' lands. Property lines literally vanished underwater. To restore order and remeasure those fields after the water receded, the Egyptians had to find a way to measure the earth. This practice gave us the word geometry, which literally means earth measurement. Further east in Babylon, the challenge was time. To track stars and predict seasons, they developed a counting system based on the number 60. Look at a clock today. The reason we still slice our minutes and hours into exactly 60 distinct pieces is a direct handoff from those ancient Babylonian astronomers. For these early civilizations, math was a physical toolkit. It provided the survival and organizational rules necessary for cities to function and grow. Around 600 BCE, the baton passed to ancient Greece. Thinkers like Euclid were no longer satisfied with just measuring a field. They wanted to know the hidden logic behind why those measurements always worked. The Greeks sought a specific kind of logical certainty. They proved that drawing squares from the sides of a right triangle means the area of the two smaller squares fills the largest one. Euclid gathered hundreds of these logical steps into a massive structured rulebook called the Elements. This shift took math from a practical set of measuring tools and turned it into a rigorous system, where every new discovery had to be proven with step-by-step logic. While learning slowed in Europe, the relay race accelerated in Asia. In China, running a massive empire required intense organization, and scholars used texts like the 9 chapters to manage taxes and trade. They used counting rods to perform rapid calculations, organizing them into columns representing ones, tens, and hundreds. It was a highly efficient decimal system. In India, scholars were charting the movements of the planets. To map these vast distances, they began exploring the concept of adding an endless sequence of smaller and smaller fractions to reach a specific total. Indian mathematicians formalized the concept of zero. Treating an empty placeholder as an actual number allowed them to perform advanced calculations with larger digits. By learning to work with the infinite and standardizing the number 0, Eastern mathematicians created the numerical system that powers our modern world. By the 8th century, the center of learning moved to Baghdad. At the House of Wisdom, scholars gathered Greek logic and Indian numerals, merging them into a single system. A polymath named al-Khwārizmī wrote a manual to help settle trade disputes and inheritance. He called his method algebra, which refers to the completion or balancing of an equation. Al-Khwārizmī treated unknown numbers as abstract shapes, balancing them like physical weights on a scale. When you move a block to the other side, you adjust the value to maintain equilibrium. This is the literal meaning of algebra. These variables provided a universal language. It allowed math to function as a tool that worked for any situation, from dividing a farm to managing the finances of an entire empire. The relay race eventually returned to Europe, reaching thinkers like Isaac Newton. They were trying to understand the physics of a moving universe. Previous methods were great at balancing equations where the numbers stayed still, but those tools couldn't accurately track objects that were constantly moving, like a falling apple or a planet orbiting the sun. Watch this curve. By combining Greek geometry, Indian concepts of infinity, and Arabic algebra, they developed calculus, a way to map continuous, unbroken motion. Calculus represents the moment where the Greek, Indian, and Arabic batons cross the finish line together to solve one of the biggest problems in science. Think about that the next time you look at a homework problem. The numerals you write were originally developed in India. The letters and balancing signs used to isolate X were perfected in the Islamic Empire. And the step-by-step logic proving your answer correct is a direct gift from ancient Greece. Mathematics belongs to no single culture or classroom. It is a vast project built by people all over the world, and every time you solve a problem, you are picking up the baton.